Everyone, good morning, welcome. I'm really glad to be here to talk with all of you about the things that we're doing at the Open Source Security Foundation to help really just elevate the state of security across the open source ecosystem. You've heard a lot about software supply chain yesterday, and you'll hear even more about it today, and the need to secure it and the ways that are vulnerable. What I wanted to talk a bit about are some of the operational things we're doing. But first, just to set the stage, this is something all of you know. Open source software is 90% of the software world. I don't care if you're talking about a car or a phone or any of the different websites out there. All of you are here because you work together on that 90%. And that 10%, maybe it's what pays your salary, maybe it's what pays the bills. So there's always going to be that 10%. But 90% of the software world is open source. And this is studies and data that gets cited a bunch of different ways. There's something actually called the Sonatype State of the Software Supply Chain deck that they've been doing for a couple of years that's always worth referencing. What might not be as obvious is that vulnerabilities, known vulnerabilities, are still pervasive through the software that we're shipping today. 29% of popular projects contain CVEs in their dependencies, sometimes even in the code that they ship out. And even the non-popular projects, the long tail, have lots and lots of known CVEs that they have yet to address in their dependencies or in their core. And the problem isn't just obviously known CVEs, it's the ways in which the software that we build and the way we choose our dependencies and pull them into to common packages and distribute them and get them to the end users, those are under all sorts of new kinds of attacks that have led to some of the more prominent breaches that we've all heard about. SolarWinds, for example, was really core to this. And if you were to think abstractly about one kind of way of looking at the software supply chain, going from the developer and the IDE and getting what's in their head to lines of code, to working on that with other people, to picking dependencies in as you do a build, and then shipping it out. There are at least 8 that we've identified here. There's probably more ways that can be attacked. And part of the reason we're vulnerable here is open source software was developed at a time where there was a whole lot of trust in people on the internet. I don't know how many of you were kind of online at this time, but I used to remember getting email from people I didn't know and being excited about that. Like, oh, you hadn't know about email too? You must be cool, right? These days you get spam and it's like, oh, I'm drowning in it. But back then, there was a bit of a presumption that if you could stand up a .org website and distribute software from it, you probably knew what you were doing. You probably took a lot of pride in your work. You probably were doing that out of just enough insecurity that you wanted other people to, check your code for bugs and that kind of thing. That was my trick. I had zero confidence in my ability to code, and the world is much better off without my code, trust me. And so I kind of conned other people into helping me find bugs in my code, and that was kind of how Apache got started. But basically, it was a very high trust environment, and we didn't even. Actually, early on, we did sign releases coming out of Apache with PGP keys and the like, but there were a whole lot of ways in which that high trust environment could be attacked, where we kind of cherished the fact that we didn't know the people behind who were other contributors to our projects, right? Other peers, other core committers. So now everything from compromised access control to code that gets out there without even a second set of eyeballs looking at it, let alone a group of people taking responsibility for it, to compromised source code systems, which still happen all the time, to all sorts of ways which really try to take advantage of that. In fact, some of you perhaps remember, I think it was last year, the University of Minnesota tried to prove how vulnerable the Linux kernel community was to this kind of social engineering kind of thing by trying to propose a set of patches that slipped a backdoor into the Linux kernel. Well, they got caught, but not before burning a whole lot of core maintainer time, so much so that the University of Minnesota is now banned from contributing to the Linux kernel. And for anybody who's worried about hackers from one country or another, like looking at this as a way to compromise, that's like a thing to remind people of is, hackers know how to use VPNs. So it doesn't matter where they're coming from in terms of whether you can trust them or not. So at the OpenSSF, and we're a project that's been going for about 2 years now, we have participants in our community. I'm sure many of you work for organizations that are part of what we do. I'll show the NASCAR logo slide in just a bit. But there's not just one solution to this problem, obviously, right? We've got working groups in a bunch of different domains, from focusing on best practices, where it's everything from the best practices badge that some of you might be familiar with. It's been around for quite a few years, to the development of educational materials for teaching secure software fundamentals, to a working group focused on vulnerabilities and how those get disclosed that has developed a guide for coordinated vulnerability disclosure to help open source projects that perhaps have not gone through a CVE process before, not gone through coordinating with their end user community to make sure people are exposed for as little time as possible. We've got a working group on just identifying security threats that tries to look at things like, how are security reviews done? Who here has been a part of a third-party code review of an open source project you've been on? Great, good to see a few of you. Nowhere near enough of that is done. Third-party code audits, and I'll talk a bit more about that in a sec, are a great way to not just look for the off-by-one error that leads to the memory exploit, memory buffer overflow exploit, but to actually challenge your assumptions about the product you've built and whether it's actually designed safely. We've got another working group focusing on security tooling that is trying to come up with all sorts of automated ways to analyze a repository, a body of code, and figure out what are some worrisome parts about what you're doing here, right? As well as to use some more computational tools around the CVEs and disclosures process to try to get a better picture of risk in an open source community. We've got another one focused on the supply chain integrity. Initially, it was kind of focused on identity, and then we realized, obviously, it's a hard problem. There's lots of people working on identity. Let's instead think about levels of attestation of process through the software supply chain. And so that's the working group that oversees SALSA, which some of you might be familiar with, and which now has been adopted by the cloud native community. And I think we just saw the first release of Kubernetes using SALSA level 4, if I'm not mistaken. We also have a securing critical projects working group focusing on things like trying to understand what are the critical projects that are forgotten about out there. What is the next OpenSSL or Log4j that everyone uses that has professionals working on it, but simply not enough, right? That is simply forgotten about. And in fact, one of the biggest things that we've done there is fund a project with Harvard to develop something called the Harvard Census, if any of you have seen that tried to look at what are the most critical projects by dependency graph analysis, as well as factoring in usage, and getting some data sources from like the SCA tool vendors and others to try to really understand that. We had to come up with a separate list for the NPM community because it was such a standout difference in the criticality ranking, simply because of the very different nature of NPM and JavaScript in terms of how atomic and how individualized kind of the different components are in the community. We have a working group that just launched called Securing Software Repositories that is all about getting the people behind NPM and PyPy and the other kind of what are essentially the iPhone app stores of our community together to talk about common systems, common protocols. How do we do things consistently across those when it comes to things like requiring multi-factor auth for developers and publishers of, say, the top 100 most important components, right? Or start to adopt things like Sig Store, which is a digital signatures platform for signing of software artifacts, or even Salsa or other things. So, and then finally, we've got a couple of key projects that are kind of hang off to the side that actually have their own funding that we have some oversight over, but we really try to stay close to. I'll go from the bottom up. One of those is called the GNU toolchain infrastructure. It turns out the build servers and the really critical pieces that are involved in the development of GCC, glibc, GDB, kind of the fundamentals that enable things like the Linux kernel and the Linux operating systems and almost all the other interpreters for other languages that we build on top of. A surprisingly few number of people who are building that on personal boxes and off to the side of corporate resources. that needed a bit more rigor. It needed a bit more, kind of like what we have for the Linux kernel in terms of build systems. And so we've been working with that community to better support the build systems that everybody depends upon to be locked down and hardened. And then two more, I mentioned Sig Store. Sig Store is basically kind of like Let's Encrypt in terms of very low levels of proofing required to get a key pair to be able to sign artifacts in the software development process, partly focused on how do we make it really, really easy, not automated, this is important, you still want a human in the loop, but easy enough to go get a key pair to sign not just the end result that gets pushed through to end users, but upstream as far as possible to make sure people are getting what they think that they're getting, right? And then finally, a project that's kind of ambitious, and we're still recruiting for this, but to put together, it's something called Alpha Omega, which is a project that is a little bit like Google's Project Zero, but focused on open source and built with a lot of thinking about how do you systematically go and scan as many different repositories out there for, let's say with Log4j, we discover, hey, parsing of untrusted input for format strings is an anti-pattern. Who else is doing that out there? And can we write code QL queries to do that? Can we write other kinds of scripts to go and look for that? And then a second part of Alpha Omega is going and providing funding for key open source projects, the alpha projects out there, who don't yet have some of the resources or community support for core security practices that we're hoping to see eventually becomes a key part of every major open source project. Things like a funded security team. And in fact, one of the first places we put some funding, 300K, has been towards the Node.js community on helping resource the Node.js security team. First, it's just about providing kind of a rapid response team to be able to respond to any CVEs that are discovered in the core of the libraries and the functionality in Node.js and the like. But it's also to try to develop a capacity in that community for more than just the one person we're able to fund, to go and build a culture of more secure development. Perhaps it's adopting other tools and other standards that, like Sig Store or Salsa. Maybe it's simply about trying to get better metrics into what are perhaps the more worrisome kinds of projects that are heavily dependent upon. How do we help instill a culture of security releases and coordinated disclosure? All those kinds of things are a part of that process. And what we're hoping to do is find a repeatability to this that then could be applied to other critical open source projects that also are understaffed on their security teams, and provide some funding to those projects as well to help them. In fact, we'll have 2 more that we'll launch soon on that front, but to also help inspire the communities we work with and the key stakeholders in that community to go, you know what? If we have a pool of money that we fund the kind of core operations of this project with, maybe we should include some more funding for kind of this security proactivity. So that's really the big idea behind Alpha and kind of what we're doing with the NPM community. This is the NASCAR slide I mentioned just to try to get across, we are trying to really work with everybody who's a stakeholder in the open source ecosystem, not just the cloud providers and the major software vendors that you'd expect, but with now the many of the financial services firms that have played such a growing role in the open source community. We're also very international in our perspective. Most of our members are in the US and a few in Europe and a few in the Asia Pacific region, but everybody has common cause here to think about how do we improve the state of security. In fact, into the 6 minutes I've left, I'm going to breeze through something really quickly that we've recently accomplished or worked on with the US government, although what we're doing here will be applicable to any government. So we've put together something called the Mobilization Plan, and let me just give you a bit of a background to this. In December, all of you perhaps saw and heard about Log4Shell, and it really sucks when you become a poster child for something that you don't really deserve. The Log4j developers are all pros. Apache has a great process behind what they do. But they missed a few things. A few things that a third-party audit might have turned up, like, frankly, do you want to really be doing parsing of untrusted user input for format strings that led to, even though they really were careful about it, led to a Jindy LDAP exploit? But it caused a big problem because it was so easy to exploit. It caused organizations, both the private sector, public sector, to really scramble to try to figure out what to do. So much so that in December, the National Security Council at the White House went around to some of us and went, are you all okay? today. Like, if you guys are the bridges and highways of the internet and of this digital culture we're all building, and something like this can pop up, like an earthquake, like a really massive, like worldwide earthquake, and cause us to have to scramble like this, where are there other problems like this we should be knowing about, and how do we reduce the chances of it happening? How do we make it easier to deal with it when it does happen? And is there something fundamentally wrong here with how open source is built? And I think all of you agree, that there isn't anything fundamentally wrong, but things that are worth improving. And so in January, the White House convened this meeting amongst a bunch of different government agencies, in the executive branch, about 10 different companies, us and the Apache Software Foundation, to talk about the problem. And after 6 hours, we kind of boiled it down to 3 kind of big overarching goals: securing the production of open source code, improving vulnerability discovery and remediation, and shortening the time it takes to fix patches. And so as an outcome of that meeting, we at the OpenSSF started to think, hey, we've got a lot of irons in the fire here, different things that we're doing, but they're all kind of not thought experiments. They're running code, but we just kind of have to put it out there and hope people adopt it, right? But what could we do if we actually said, let's really invest in getting this stuff out there and driving adoption? Because you all know there's things you can invest in from a DevRel point of view, from a building of core code that doesn't just show up on its own kind of point of view. With those 3 goals, what are the major problems that we might be able to address when it leads to building better open source software and addressing those issues in the software supply chain? Where are there pre-existing efforts, whether inside the OpenSSF or not, that are already starting to address those problems? Things that are like experiments that are proven, or things that are demonstrable that we can just double down on or put 10x the effort into repeating. Building on those efforts, what are the resources we'd need? If money were no object, but it's always an object, but if you had enough money to go and solve these problems, what would it take? And what would be a reasonable strategy to have impact, a demonstrable impact on this within the first 2 years? So we developed this mobilization plan, which is really the first time I know of in at least the Linux Foundation that a community has tried to systematically ask these big questions and be ambitious. Usually we at the Linux Foundation, we're like the air traffic control tower, with all of you kind of like trying to land your planes at on a common runway, and here's the runway for CNCF or for Kubernetes, here's the runway for this or that. But typically we take a very, I don't want to say passive role, but very much we're about facilitating all of you. But if we were to be a bit more top down and try to really drive an impact with our community, what would that look like? And so we developed, along with our governing board and all the experts in our community, a plan that kind of to our surprise called for $150 million in funding over 2 years on 10 different themes. And I've got 2 minutes and 48 seconds left to walk through each of those 10. So I won't do them justice at all. We've got the plan up for download. I want to be clear, the plan is version 0.9.1. It's not done. It's things that, plans that will continue to evolve. But we rolled it out in May in a room with, again, all the same people that we had at the first meeting from government, along with our own members and a bunch of other open source projects and the like, reviewed it together. And actually in that conversation, both with the government, it was like, how do we align this with what the government's already doing? We weren't there to like put a handout to the government to pay, to put money into this plan just yet. We'll see what happens over the course of time. We're having some other conversations with other governments too. But from our own community, we raised $30 million in pledges against that plan. Now, we're still having to figure out where that goes and how that gets applied. As a really quick scan of those 10, the first one is focused on secure education, on teaching software fundamentals. We've got courses up on both edX and the LF training portal that take about 20 hours to go through. It's not a huge thing. It's half of a work week that goes through all the major kinds of, how do you program defensively? How do you think like somebody who's going to red team your code, right? How do you not assume that security by obscurity is enough, right? How do you work with these things? We want to take that courseware and blanket the world with it, right? And get companies to adopt it as a standard for when their developers engage in open source software, even write code for them, right? All these other things. The first is, how do we get that everywhere? The second is, how do we develop kind of a risk assessment dashboard dashboard, kind of like some of the stuff Feroz showed you yesterday, which is on a project-by-project basis, how do I understand how risky this code is? Or if I'm looking for a new module that does X, here are the 3 different ones that do it, and assembling as much objective data as we can about the things that we know make for more secure software. How do we help people choose the more secure alternatives or help developers understand what they can do to change that? How do we drive more adoption of digital signatures throughout the software supply chain based on Sig Store, but interfacing with other digital systems? How do we look at memory safety issues? And this includes rewriting some core libraries that are today in C that, you always have that memory safety issue into things like Rust or Go. How do we develop an incident response team that can work with open source projects when they get their first, security notice that looks like a really big deal? Who will they call? Who could they call to help them manage a response to this, make sure their patches are the right one? We know you can't just go and put new mandates on open source developers. You have to show up with help. So an incident response team for that. How do we do more and more scanning, some of the stuff I talked about with Alpha Omega, and get really systematic in trying to cover 10,000 different, the top 10,000 open source repositories with that? How do we fund more code audits? To help really prompt developers into being certain about the stuff that they've built. How do we do more data sharing? And this involves some sensitive data about which components are used out there most widely in a way that helps us get better information and just make sure where we're spending money is more targeted and focused. How do we drill into SBOMs? That's a huge other topic I'm happy to talk more about later. But where might we invest in core libraries that push as far upstream as possible the production as well as the consumption of software bill of materials as a key data part of shipping any package. And then finally, where are there other places in the infrastructure to invest in improving the software supply chains, both those major distribution hubs and the gatekeepers there, or other places upstream where better practices and better default tooling so that it's built in, so you don't have to lift a finger to be more secure about what you do. Altogether, this called for $70 million the first year, $80 million the second year. This is ambitious. This is still a work in progress, but this is pretty well vetted, and we're pretty confident about where this heads. And we're really happy to see the 30 million pledges arrive from our community. It's a drop in the bucket to what we need, but it was great validation that we're on the right course here. And just as a last thing, I know $140 million, $150 million might sound like a lot, but a bigger number than this, $700 million, was the fine that the FTC levied on Equifax after the 2017 data breach that they had because they failed to update Apache struts quickly enough. And so as a leveraged piece investment, this is going to really pay off. And the FTC has already said they're going to go after organizations that suffer data breaches if they haven't updated their instances of Log4j. With that, get the plan, join us in the OpenSSF on the projects we're working on. We're really eager to help uplift everybody in the community. We know all the communities are different in how they build code, and so really eager to go and meet you where you are and provide tooling to make everything that we build more secure by default. Thank you so much.